The best way to use this video is to watch and pause at certain points and see if you can answer the question yourself. The video is very similar to how we work problems in class. I will lead you to a point and then I'll ask you to think about what comes next. Please pause the video and do that good thinking. It will speed up your mastery of the material. If you come back from having decided on what you think the answer is and play the video again and it turns out you got it right, fabulous, proceed. If you did not get it correct, then I would ask, go ahead and watch the rest of the video, but make a note of it and follow up with me or your lab instructor or your tutor, because questions like this can really help us to learn and master physics faster. It could be your idea was a completely fabulous one that was just another way to solve the problem. Recall, many of the problems that we work will have more than one correct route or answer. Or it could be that you have a concept or equation misunderstanding, and that's learning. And if we can sort it out, then the next time you encounter it, you'll get it right. Let's start out by reading the problem and getting our information organized. We can see that this problem has two different vehicles or two different objects, both traveling in one dimension. So we're going to have to organize our information very carefully. Sue's information and the van's information. They're driving initial speeds that are different, and one of them is decelerating and one is not. So we need to carefully gather that information from the problem and get it organized. Pause the video and consider what we're looking for. All right, so the problem is asking if they have a collision, and if so, what location are they at when that collision happens? And then part C is what time does it happen? What does it mean to have a collision? It means that they're at the same place at the same time. Pause the video and sketch the problem. I'm going to start by putting down my origin, and my origin is going to be the 0, point of the origin is going to be where Sue is at the start of our problem. And I'm going to put Sue and the van on the axes where the van is 165 meters ahead of Sue. Now in this problem, they're both going to be moving to the right, at which at some future point in time, we want to know if they're at the same spot. So we can write that the initial location of Sue is 0. And the initial location of the van is 165 meters. Let's go back to this idea of what does it mean to have a collision in terms of physics terms or physics variables. It means, is there a moment when the location of Sue, the final displacement of Sue, is the same as the final displacement of the van? So I'm going to write out the kinematic equation for the displacement of Sue and the kinematic equation for the displacement of the van. So let's go back and look at our problem again. What is the acceleration of the van? The van is just traveling at a constant speed, so that means the acceleration for the van is 0. So that last term in the van equation drops out, and I'm going to rewrite my equations, simplifying a little bit. So I want to ask myself, do they ever have the same location? So I'm going to set displacement of Sue equal to displacement of van. Let's start substituting in our knowns and simplifying. All right, and now we can recognize that because we have a t squared term, a t term, and then a term that has a numerical value but no t in it, I'm going to need to use the quadratic formula to solve this. And I will get 2 roots. I'm going to pick the smaller of the 2 roots because notice they're both positive. The second one of those roots would be if the collision, like they just pass through each other and when they might meet up again later. And we're really interested in that first time that they're at the same location at the same time. What was that? Let's look at the picture. So the van moves forward and Sue moves forward, and I'm kind of showing this would be the first time that Sue and the van are at the same location. Now we all know that they would actually collide here and everything would be done. But if they could pass through each other, then Sue would continue on. Now she's still decelerating, and eventually the van would catch up and they would be at the same location at the same time, but it would be a later time. And that's what that second root is from our quadratic formula. All right, back to using that first time to solve for the location. I'm going to take the equation for Sue and substitute in the t that I just found. And there you have it. There is the location. And there is the time, which we already found.